Hi, this is a screencast looking at fatigue with respect to the fatigue of energy systems. We have a webcam in this evening as well, just thought we'd see how that goes. Okay, so looking at fatigue, we have a couple of levels of fatigue. The first one that we look at is the one that we experience when we're actually doing physical activity, and that's local fatigue. So here we're looking at a particular muscle group or body part that's been the focus of a training session. So for example, with our water running track today, no doubt people ended up feeling fatigued within their quads, hamstrings, maybe a little bit through the core and also the arms. We then have a level of general fatigue. So this is once we have done an extended training program, or it could be an endurance type event, such as a half marathon, but it's the feeling in all muscle groups that we get afterwards. And then the final stage of fatigue is chronic fatigue. So chronic fatigue is an unhealthy level of fatigue, and it's the continual breakdown of body's defense. When this occurs, it is generally because we have not been able to recover sufficiently between training sessions. So we continually train in a fatigued state. So the level of general fatigue gets worse and worse, and in the end we end up with chronic fatigue. So we could have chronic fatigue syndrome, end up with overtraining injuries, recurrent minor colds, so we're just not able to get over these, insomnia, so with chronic fatigue it's difficult to sleep, and also recurrent viral infections. So this is a table that looks at types of exercise and the nature of the fatigue. So this is to do with energy production again. So here we're looking at anaerobic exercise. The fuels for the anaerobic energy systems, we have phosphocreatine or creatine phosphate, that's within the ATP-PC energy system, and we have carbohydrate, that being within the anaerobic glycolysis system. So how do they affect fast twitch muscle fibers? Fast twitch muscle fibers are larger in size, they generate more force within a shorter period of time than slow twitch. They are the muscle fibers that we will preferentially recruit when doing anaerobic exercise. Our stores of PC will deplete quickly as a result of high intense activity. That's because the creatine and phosphate will split, releasing energy for muscular contraction, hence the resynthesis of ATP. So that's looking at phosphocreatine. Our levels of carbohydrate or glucose will also decrease as they're being used within the anaerobic glycolysis system. So the breakdown of glucose there, releasing energy to resynthesize ATP as well. Looking at aerobic exercise, we have the three fuels, but we're not going to look at protein. So again, carbohydrate or glucose being broken down, again releasing energy for muscular contraction. We have our fats, or in our muscle we have triglycerides. The level of triglycerides will decrease as exercise continues, as they're being used also within the aerobic energy system to resynthesize ATP. So we've looked at a decrease in muscle stores of fuels. Now we're looking at the buildup of metabolic byproducts. So our metabolic byproducts are compounds that are made as a result of our chemical reactions. So they're described here as leftovers. The first one that we're looking at is creatine phosphate splitting, and also the same thing will occur when ATP splits. So if we start off with adenosine triphosphate, we end up with one phosphate splitting off, which is our inorganic phosphate. Very similarly, if we have creatine phosphate and the creatine and phosphate split to release energy for resynthesis, we end up with our inorganic phosphate as well. So how does that actually cause fatigue? So when we have a build-up of our inorganic phosphate, it hinders the release of calcium ions. Calcium ions are required for muscular contraction to occur. So if we end up with a decrease in the amount of calcium ions being released into the muscle, it means that the muscle will contract with less force and less quickly. So hence, force of contraction decreases, rate of contraction decreases, which obviously then leads to a decrease in intensity. So build-up of inorganic phosphate leads to a decrease in calcium ions being released. The next one is looking at the accumulation of lactic acid. Now the next slide will look at this also. With an increase in lactic acid, and this is primarily looking at the increase in hydrogen ions, we have an associated decrease in pH or increase in acidity. What this leads to is a decrease in glycotic enzyme activity. Now, the importance with a decrease in glycotic enzyme activity, it means that our glucose is not being broken down. Now, if we cannot break down glucose, then we cannot use anaerobic glycolysis as a method of resynthesizing ATP. And likewise, we also can't use aerobic glycolysis, so the use of the breakdown of glucose within the aerobic energy system as well to resynthesize ATP. So how does that cause fatigue? Well, if we can't use those systems to resynthesize ATP, we can't resynthesize as much ATP, therefore rate of energy production decreases, therefore intensity decreases. Important figure, athletes will find they must reduce intensity of activity to sub-maximal levels, so looking at 60% of max heart rate, which we talked about in class, in order to continue performing. So it's not going to be until approximately less than 60% max heart rate that our body will start to oxidize our hydrogen ions and our lactate. The other thing, like the buildup of inorganic phosphate, is that we're going to inhibit the release of calcium ions If calcium ions are not released, then muscular contraction won't occur. So that is what we have already talked about here with accumulation of hydrogen ions. Now looking at sweat. So our core temperature increases during physical activity as a result of heat being produced from the breakdown of ATP and also of the food fuels to resynthesize ATP. Now sweating, natural process to cool the body. However, when we sweat, we end up with some form of dehydration, unless of course we're using an appropriate sports drink or water to be able to rehydrate. The benefit of sports drink over water when we're doing physical activity is that it will contain the electrolytes and salts that the sweat contains. So if we're looking at anywhere, even if it's 2 to 3% of dehydration, it looks at impairing both coordination and physical endurance. It will also impair our mental agility, well, our mental processing. So our ability to think appropriately on the sports field is also decreased. So looking at recovery. Recovery with respect to PC stores. This piece of text, which is from another of the BCE textbooks, indicates that up to 70% of our PC stores can be replenished in the first 30 seconds of passive recovery, and that the remainder up to about 3 minutes. The text that we use has it as 50% in 30 seconds and remainder in 2 to 3 minutes. And this is looking at passive recovery, so where we're sitting down doing little if any physical activity, because if we do any type of physical activity, we will actually start to again use what we are replenishing. So it is passive recovery with respect to the ATP PC system to replenish our ATP and PC stores. Now, breakdown and removal of lactic acid. Here we want to do an active recovery as opposed to passive. So the passive is what we don't want to be doing. And the reason why we want an active recovery is that it means our body is still moving, so heart rate remains elevated, oxygen intake and uptake remains higher than resting levels, so we can actually get more oxygen to the muscles that have worked so that we can help to oxidate the hydrogen ions and lactate. So again, the reason why we would want active with respect to passive when looking at times is that 50% for an active recovery, 15 minutes, for passive, 30 minutes, approximately 100%, so we're going to say about 95%. We're looking at 30 minutes with an active recovery and 60 minutes with a passive recovery. So hence why we don't want to use a passive recovery with the oxidation of lactic acid and hydrogen ions. If here we have a quick look at our oxygen deficit and EPOC, so here's our energy demand during physical activity. Let me start here. So that's exercise, that's recovery. This area here is our oxygen deficit. This area in here is our oxygen consumption. And then this bit underneath the line being epoch. So we have two parts of epoch. We have a fast part and we have a slow part. So if I write something like this, this is part one, our fast part, part two, our slow part. Part one is looking at the replenishment of ATP and PC stores. Number two is looking at the oxidation or the breakdown and removal of lactate and our hydrogen ions. So again, looking at just some times, this is what we have just explained. What we haven't had a look at here is glycogen restoration. So glycogen restoration is how quickly are we able to replenish the body's stores of glucose. So a minimum here, we're looking at following intermittent activity. So 30 minutes to 24 hours. So it's a big range. And that's going to follow continuous activity from 2 up to 24 hours, though unlikely that activity would take 24 hours. Intermittent activity of 2 to 24 hours, we're looking at 1 to 2 days. So the longer you work for, then we're looking at a longer period of time for the replenishment of glucose stores. The next little flow chart is a chapter summary from our textbook. So just going over this, we've looked at fuel depletion. We've had a quick look at oxygen deficit and epoch. Steady state, just a reminder that steady state is when oxygen supply will meet demand. So the vast majority of any required energy can be resynthesized via the aerobic system. Oxidation of byproducts is used within an active recovery. So the oxidation of byproducts are the lactate, hydrogen ions. Passive recovery is used for our restoration of PC, because if we do an active recovery, we will use phosphate, creatine and stored ATP. Recovery strategies, how long until next event or training, may depend on, again, what type of recovery you do. It's more likely to want to be in an active recovery if we need to, again, break down lactate and hydrogen ions to allow performance to improve. If it's something like a long jump, then the next effort may be in 5 minutes. It's an ATP PC based activity, so passive recovery would be important there. Looking at restoration of fuels, then if we're using a drink, then are we going to have use for sports drink, or are we just going to use water? Gels, a very high concentration in carbohydrate or glucose, so they would need water with them as well. We look at this in greater detail in Unit 4. What we haven't particularly looked at in a lot of things is the neuromuscular fatigue. We've looked at hydrogen ions increasing and therefore decreasing calcium ions. We've looked at a buildup of inorganic phosphates and also adenosine diphosphate and its relationship with decreasing calcium ions. Lactic acid, good or bad? Well, the lactate, not bad. So lactate's okay. It's the hydrogen ions of the lactic acid that are bad. These two going to have a quick look at. Central nervous system fatigue. So this is where our brain recognizes that we're fatigued. So it sends a weak signal to the body. Therefore, with a weaker signal for muscular contraction to occur, our muscular contractions will occur less frequently and will recruit fewer motor units. If we're recruiting fewer motor units, we're going to have the effect of decreased force. So, again, central nervous system fatigue. Our brain sends weaker signals, which decreases both the frequency and force of contraction. So therefore intensity decreases. When we have an impaired sodium and potassium gradient, this decreases the release of calcium ions. If calcium ions are not present or fewer are present, then again muscular contraction will occur less frequently and with less force. And the last one we're going to have a look at, redistribution of blood flow. If we need to cool ourselves and we have an increased blood flow to the skin, it therefore means that we have less blood going to our working muscles. If we have less blood going to our working muscles, we have less oxygen at our working muscles, which then in turn decreases rate of energy resynthesis, and that obviously leads to a decrease in intensity, hence we fatigue and slow down.